Hey everyone, have you ever stood in front of a massive rack of blinking lights in a server room and just thought, what in the world is all that hardware actually doing? Well, you are definitely in the right place. Today, we're doing a deep dive into the absolute unsung hero of the modern office, the network switch. Let's peel back the curtain together and figure out how local area networks actually work and uncover the incredible digital intelligence running behind the scenes. Okay, let's dive right into this. Here is our roadmap for the explainer. First up, the heart of the LAN. Number 2, decoding the link lights. Third, inside the smart brain. And finally, we'll wrap up with the golden tech rule. I want you to just take a second and picture your typical office environment. You've got rows of computers, maybe some Wi-Fi access points mounted up on the ceiling, servers tucked away in a back room somewhere, and a couple of those heavy-duty printers in the corner. When you hit print and, cross your fingers that it actually works, or when you pull up a shared file from a coworker sitting all the way across the floor, that data has to travel. But how? What is the invisible infrastructure making it all happen seamlessly, instantly, and reliably? All right, Section 1, the heart of the LAN, the building blocks of local networks.
The answer to that office mystery is the network switch. You can think of a switch as a super smart central controller. Its primary mission is to connect all your endpoints, so your computers, your printers, your local servers, so they can talk to each other directly. What's absolutely crucial to understand here is the local advantage. A network switch allows for massive, high-speed data sharing inside the four walls of your building without ever needing to touch the outside internet or eat up your external bandwidth. It keeps local traffic local.
Physically, these devices are incredibly dense. You'll typically find them in 8, 24, or even 48 port configurations. Each of those ports is essentially a docking station for a standard RJ45 Ethernet cable. Just imagine a 48-port switch for a second. That is 48 individual devices wired directly into a single centralized box. It creates this incredibly dense web of localized connections, and that exact web is what forms your local area network.
Moving right along to Section 2, decoding the link lights, reading the physical layer.
Now, what's really interesting here is that a switch isn't just a silent, dumb box of cables. It constantly communicates its status to us, if we know how to look. This is basically a literal cheat sheet for decoding those LED states, following a simple rule of 3. First, look for a solid green or amber light. That's great news. It means the physical link is up, the connection is established, and the device on the other end is powered on. Second, if it's blinking furiously, data is actively passing through. But check out that bottom row. If the light is completely off, you have a physical layer problem. Let's spend an extra second on that dark port, because this is vital. A dark port always means a physical failure, every time. It's an open circuit, a physically cut Ethernet cable, an unplugged port, or maybe just a dead computer on the other end. And here's a fascinating takeaway to keep in your back pocket. If that light is off, literally no amount of software magic will ever fix it. The hardware connection itself is broken.
Let's transition from the physical layer over to the digital intelligence in Section 3. Inside the smart brain, the magic of MAC addresses.
So you might be wondering, what exactly makes a modern switch so smart compared to older legacy technologies like network hubs? Years ago, hubs were the standard, but they were, honestly, incredibly inefficient. Switches completely revolutionized the office LAN. So what's the secret sauce here? Let's find out. The secret lies in something called MAC address awareness. Every single network card inside every computer, printer, or server has a MAC address. It is a hard-coded, 12-character unique hardware fingerprint permanently burned into the device at the factory. Think of it like a digital serial number. Just like human fingerprints, no two devices on Earth share the exact same MAC address.
And this brilliantly illustrates how the switch becomes the ultimate traffic cop. It doesn't just sit there blindly, it actively listens to the network traffic. It learns exactly which MAC address is plugged into which specific physical port, dynamically building this incredibly precise map of every single device in the building. It memorizes the exact physical location of everything connected to it.
To really put that into perspective, let's contrast it with the old stuff. Old technology like a network hub didn't have a brain. If computer A wanted to send a file to computer B, the old hub would blindly broadcast that file to every single port on the network. Actually, it was more like it was screaming the data down the hallways, just hoping the right computer heard it. It wasted massive amounts of bandwidth and caused terrible congestion. But a modern switch? Because of that MAC address table, it uses targeted delivery. It takes the file from the source port and sends it directly, and only, to the exact destination port. No data is leaked anywhere else, no bandwidth is wasted. It is just pure, targeted efficiency.
Okay, on to our final piece, Section 4, the Golden Tech Rule Field Troubleshooting Framework. So in enterprise environments, the switch where daily office users plug their computers in is called the access switch. Sitting at the very edge of the network infrastructure, this device is a field technician's bread and butter. If you work in IT, you will spend most of your time right here, troubleshooting user connection issues.
Let's see how all this builds into a highly logical 3-step action plan that relies entirely on using your eyes first. Step 1. When a user complains they have no internet, go eyeball the port on the access switch. Step 2. Check the link light. If it's dark, you immediately know it's a physical issue, so you swap the Ethernet cable, verify the power, or check the wall jack. Step 3. Troubleshoot IP addresses and software configurations only after getting a solid light.
So the absolutely crucial point here boils down to this fantastic rule of thumb. Never troubleshoot software for a dead physical link light. It is wild how much time gets wasted tweaking IP configurations, rebooting systems, or messing with network settings when a literal cable is just unplugged under a desk somewhere. Fix the physical layer first, get that green light, and then move to the software. It's a golden rule that will save you hours of frustration.
Wow, okay, we have covered a ton of ground today, from RJ45 cables and LED states to dynamic MAC address tables and targeted data delivery. You've seen exactly how the hardware and the software unite to form the true backbone of the local area network. So, I want to leave you with this thought. Next time you walk past a server room and see a massive box of blinking green lights, what invisible fingerprints will you picture flying through those cables? Suddenly, it's not just a box of wires anymore, is it? It's an incredibly smart, highly efficient central controller silently directing digital traffic at the speed of light. Keep learning, keep observing, and I'll catch you in the next explainer.